Hey everyone, this lesson is about perpendicular bisectors and using perpendicular bisectors in triangles. First, I want you to get started by doing a couple warm-up exercises, solving these algebra problems. So pause the video, work them out yourself, and I'm going to provide the solutions for you. Number 1, in solving this, you get negative 5x is equal to negative 15, which means x is equal to 3. Number 2, in solving this one, you should get 17 equals 2x, which means x is equal to 17 over 2, or as a decimal, 8.5, 8.5. And finally, number 3, since we're dealing with a midpoint, if you were to draw a picture of segment AB, where M is the midpoint, you know that these two segments are equal. So all we're going to do is set up the following equation. 5x minus 2 is equal to 3x plus 6. And in this equation, x is equal to 4. But it's asking you for the length of AB. So plugging in x, you get AB is equal to 36. Given that BD is a perpendicular bisector of AC, we want to find the length of segment AD. By the perpendicular bisector theorem, we know that AD is equal to CD, which allows us to just substitute those expressions in. 5x is equal to 3x plus 14, and this is by substitution. And finally, when you solve this, you end up with x equals 7, and they were asking us for AD, so we need to plug that back in for AD, and you end up with the length of AD is equal to 35. In this next example, we see that WX is the perpendicular bisector of YZ, and we want to determine what segment lengths are equal. And hopefully this is pretty obvious to you. I'm going to list the answer, but keep in mind you're going to need to justify your answers. So there will be a practice problem coming up where you have to write the reasoning for your answer. So first of all, you can see that Vy here is equal to Vz because it's shown in the diagram. That would be your reasoning. They both have a length of 25. So that's one part of our answer. Vy is equal to Vz. Next, hopefully you can identify that xy is equal to xz. And I'll verbally say for you what the reasoning is. It's because Wx bisects yz. And that's the definition of a bisector. Finally, Wy is equal to Wz. And that's just because of the perpendicular bisector theorem. Wx, or W actually, is the perpendicular bisector there of YZ. So there you have it. Those are the answers of the segment lengths that are equal in this diagram. Next, we're asked if V is on line WX. Let me start by saying the answer is yes, and here's the reasoning. V is equidistant from Y and Z, and actually this is the converse of the perpendicular bisector theorem. So if you're asked this type of question, is that point on that line, then you would say yes by the converse of the perpendicular bisector theorem. These next two questions are for you to try on your own, so pause the video and then come back and check for the solutions. So first of all, in this picture, JK is the perpendicular bisector of NL, and you need to explain your reasoning for which segment lengths you think are equal. So pause the video, write down what you think, and then come back and check your answers. the length of ML is equal to the length of segment MN. The length of NJ is equal to the length of segment JL. And the length of KN is equal to the length of segment KL. The valid reasoning for these statements would be ML and MN are equal from the diagram. They both equal 8. NJ and JL are equal because JK bisects NL. So that's the definition of bisector. And finally, KN and KL are equal by the perpendicular bisector theorem. Find NK on your own, pause the video, and then come back and check the solutions. So in order to find the length of NK, you need to identify, using the perpendicular bisector theorem, that NK has the same length as LK. So we would say 6x minus 5 is equal to 4x plus 1. And then solving for x, we get x is equal to 3. Therefore, the length of segment NK is equal to 6 times 3, because it's 6x minus 5. 6 times 3 minus 5, which is 13. This next example is just really meant for you to read through on your own and comprehend as an example of applying perpendicular bisectors to a real-world situation. So in this scenario, we have these 3 points outside of a city, point A, point B, and point C. And as you can see, those 3 points form a triangle. If we want to find the location that's equidistant from these 3 different points, we're going to be using the perpendicular bisectors within that triangle. So we can use that theorem to find a point that's equidistant from the 3 points by using the perpendicular bisectors. So you would, in order to solve this type of problem, copy those positions that were given in that original picture of A, B, and C. So if we copied A, B, and C onto our graph paper or onto any other paper, we'd have this triangle right here. We would use a ruler and a protractor to draw the perpendicular bisectors of triangle ABC. So the perpendicular bisector of AB, we would draw it and it would be right here. To draw the perpendicular bisector of BC, with a ruler and a protractor, that would be this line right here. And finally, the same thing for segment AC, the perpendicular bisector would be drawn right through here. Notice the point where all 3 of those perpendicular bisectors intersect, let's call that point D, that's the location that's equidistant from A, B, and C. Alright, read through this example, and I want you to try to sketch the image and figure out where the location would be equidistant from the 3 points A, B, and E. In sketching triangle ABE and trying to accurately draw the perpendicular bisector of segment AB, I have this blue dotted line here. Doing the same thing for segments BE and segments AE, if you draw all of the perpendicular bisectors, they do all intersect at a single point right about here. And that is the point that is equidistant from A, B, and E. Alright, to finish this lesson off with a couple practice exercises, I would like for you to solve for the length of segment AB. Since we know AB equals BC by the perpendicular bisector theorem, we can say that 3x plus 1 is equal to 4x minus 7, which means x is equal to 8. Therefore, the length of AB is equal to 3 times 8 plus 1, which is 25. Try this one on your own and then check your answer. So again, we know that in this case, AB is equal to BC, and that's by the perpendicular bisector theorem. Therefore, we can set those expressions equal to each other. 5x plus 7 is equal to 7x, and therefore x is equal to 7 over 2, which we can write as a decimal 3.5. And plugging 3.5 back in for AB, I'm just going to multiply by 7. So the length of segment AB is 24.5. That is the end of this lesson on using perpendicular bisectors.